Today we are in section 4.1 and the objective is drawing angles in standard position. So first thing we need to discuss is that there's two types of angles. There is what we call positive angles, and then there's what we call negative angles. And the positive versus negative is just indicating the direction in which we go around the axis. So a positive angle travels counterclockwise. Whereas a negative angle will travel clockwise. So we're going to discuss the basics of how to graph angles, and the basics can be applied to both. It's just the key thing you need to remember is which direction you travel around the axis if you're positive versus negative. So the next thing I want to talk about is just some terminology that you're going to need. So some terms. So when we're graphing angles, we always start with an axis, and your initial side will always start right here on the positive x-axis. So this is what we call the initial side. The terminal side would be the second piece to the angle, so that way you can kind of figure out how the angle is created. So the angle is created essentially of two rays. So your first ray is your initial side, and let's say my second ray is down here in the third quadrant. So this is what we would call the terminal side. Then you have to indicate the direction in which we go around. So we would draw that little third piece to say, okay, the angle started on the initial, and then it opened up, and this is where it ended on the terminal side. So that is kind of the general idea on how we graph angles. Okay, we're going to focus mainly in radians, and then we'll touch on degrees very briefly. So we're just going to, again, let me give you real quick a basic. So if I had this, if this is my initial side, this is where we would call 0 radians. And in yesterday's lesson, we discussed that one full circle is 360 degrees, or 2 pi, and half a circle is 180 degrees, or pi. So if you imagine that this x-axis is a straight line, we know that there's 180 degrees in a straight line. So on the negative x-axis side is where we would label pi, because pi is equal to 180 degrees. So notice your positive y-axis is sticking straight up. So if I have 0 and I have pi, well, halfway between the two would be half pi. And then once you know what each quadrant goes by, you're able to kind of work your way around the circle. So if this is pi over 2, this means that next side is 2 pi over 2, which reduces to be pi. If I added it again, I'm at 3 pi over 2. And if I add it one more time, I'm now at 4 pi over 2. And 4 pi over 2 is equal to 2 pi. And we discussed yesterday that one full time around is equal to 2 pi. So that's how we're going to kind of work our way around these circles. So for our first example, they want you to graph the angle. And again, just write this direction one time. We'll do several examples. So graph the angle. And this symbol is what we call theta. So we're graphing the angle of pi over 4. So strategy that I think works the best is to start by drawing your xy axis, label the 0, and on the left hand side we label it pi. Then you look at the denominator of the angle that's given. So it's pi over 4, so 4 is the denominator. So I'm going to change this to be 4 pi over 4. Now notice 4 pi over 4 would reduce to be pi. So I really did not change anything, I just made these fractions more compatible. Then we go back to the idea, well, if on the right side is 0 and the left side's 4 pi over 4, exactly halfway in between would be 2 pi over 4. And now that I figured out that 2 pi over 4, every quadrant goes by 2 pi over 4. So that means this one down here would be 6 pi over 4, and over here would be 8 pi over 4, and I could keep going. Now I'm not going to keep going because I needed a 1 pi over 4, and I have enough information to figure out where 1 pi over 4 would fall. A 1 pi over 4 is going to fall exactly halfway between 0 and 2. So my initial side starts at 0, the terminal side would end at 1 pi over 4, and then the last part you need to draw is how the angle traveled. So my angle started on my initial side and it traveled up, and that is where it ended. So this would be your final answer. Let me make that a different color. There you go. So this would be your final answer. This is what a 1 pi over 4 looks like. So let's try another one. So for example 2, alpha equals 5 pi over 4. And you're going to see a different, all these different Greek letters, so I want to start getting you familiar with the name of these. So this one that looks like a fish is what we call alpha. So again, we're going to start by making our axes. So this is 0 over here, and this is pi. So my denominator is still 4. So again, I'm going to make this be 4 pi over 4. And I know halfway between 0 and 4 pi over 4 is a 2 pi over 4. So this means I'm going by 4s, or by 2 pi's over 4s. So 2 pi over 4, 4 pi over 4. Down here is 6 pi over 4. So as soon as I can figure out where 5 would fall, I can stop. So 5 pi over 4 is going to fall in the third quadrant, and my initial side is right here, and the last thing we need to draw is how I traveled. So because it's a positive angle, I start in the initial side and I go counterclockwise, and that is my angle. So let's do one more together, and now we're going to talk about a negative angle. So this is a beta, that's the way we pronounce that, and let's do a negative 5 pi over 6 for this one. So we start the same way. I'm going to draw my axis. So this is 0. And now since the angle is negative, this is still pi. It's just now a negative pi. So regardless of how I go 180 degrees, if I go counterclockwise or clockwise, I still end up at the same spot. Now notice the denominator is different. The denominator is now 6, so I'm not going to label this 4 pi over 4. I'm going to label this 6 pi over 6. So this is going to become negative 6 pi over 6. So now I need to figure out, well, what's halfway between 0 and 6 pi over 6. So halfway would be a 3 pi over 6. Since it's a negative angle, everything is now opposite. So my negative 3 pi over 6 goes directly down instead of directly up. And now I can say, okay, well, each quadrant represents negative 3 pi over 6. So notice, every problem is specific to the denominator. It will change every single time. So negative 3 pi over 6, negative 6 pi over 6, that means up here is a negative 9 pi over 6. And I could keep going. This would be a negative 12 pi over 6. But obviously I don't need to keep going because I have enough information to figure out where 5 falls. So my initial side is still here on the positive x-axis. My terminal side is going to be somewhere in quadrant 3. But now notice I have a 3 and a 6. So 5 is going to fall closer to the 6. So I would say my angle is going to end right there. And to draw how we traveled, I start on the initial side, but now I go clockwise and I travel in the opposite direction. And that is your final answer for a negative 5 pi over 6. So that is all for today. We're going to pick up with this tomorrow.